The machine that shouldn't exist. What if a machine could see beyond the very limits of reality itself? Not a poetic metaphor, but a telescope so radical in its conception that most scientists insisted it could never be built. Its name is never. Spoken in public journals, only whispered in private correspondence between physicists who dare to imagine. Unlike ordinary telescopes that rely on collecting light, this instrument was engineered to capture disturbances in the very substrate of space-time. Think of it less as a lens, more as a stethoscope pressed against the heartbeat of the universe. Its design defies convention. Arrays of supercooled quantum detectors nested in a ring of negative energy coils, a framework more akin to science fiction than laboratory practicality. By all accounts, it should not function, and yet impossibly, it does. Traditional astronomy offers us breathtaking portraits, galaxies colliding, stars igniting, black holes devouring, but always we see only the afterglow, the echoes of processes millions or billions of years old. This telescope claims to peer elsewhere into what some researchers half-jokingly call the unrendered layers of reality. Instead of photons, it registers fluctuations, mathematical whispers that hint at structures neither past nor future, but something stranger, possibility. In its first activation, it mapped distortions that didn't correspond to any known celestial body. They appeared like shadows without sources, as if the universe itself contained drafts of unfinished worlds. Skeptics argue the data is noise, a grand mirage conjured by the quirks of unstable quantum sensors. Yet even they admit the consistency is unnerving. Each run produces patterns too deliberate, too persistent to be dismissed. The team behind it believes they are glimpsing a hidden scaffolding beneath observable space, a geometry the cosmos was never meant to reveal. Some call it an intrusion into the private architecture of existence. Others call it madness. And here lies the paradox. If the machine is real, its implications rewrite everything we know about the universe. If it is
not, then why does its hallucination seem so consistent, so purposeful? Either answer terrifying.
For perhaps the greatest mystery is not what it shows us, but why it was ever imagined at all. And so the story begins with a question. What happens when humanity dares to look where it was never invited to gaze? Whispers older than light. Imagine uncovering a voice that predates sound itself, a murmur echoing from before the first stars were born. That is the paradox confronting those who analyze the strange shadows registered by the impossible telescope. To describe them as shadows is misleading. They are not cast by matter, nor are they the absence of light. Instead, they emerge as negative imprints on the quantum fabric, void-like fingerprints left where no object should exist. Their signal predates even the cosmic microwave background, the afterglow of the Big Bang that has long been considered the oldest relic of creation. If this data is genuine, it means the telescope is revealing whispers older than light itself, as though some primordial script still lingers beneath the cosmos. We know conventional cosmology rests on an elegant foundation. The universe erupted in the Big Bang, expanded, cooled, and eventually gave rise to stars, galaxies, and everything we observe today. Light, traveling across billions of years, allows astronomers to rewind the clock, peering back toward that singular moment of origin. According to this model, there is nothing older than the microwave background radiation, no observable structures, no earlier echoes, but the telescope's findings contradict this. Its readings suggest patterns embedded in a deeper stratum, hints of organized structures existing before the supposed birth of time. The data arrives as interference waves, recurring, motifs etched into space-time like ancient carvings beneath layers of rock. Some resemble spirals, others lattices, as if geometry itself were whispering across eternity. At first glance, researchers dismiss them as artifacts, random interference from overlapping signals. Yet repetition across multiple calibration revealed something uncanny. The shadows form coherent alignments that persist regardless of observational angle. No known astrophysical process explains such stability. If these phenomena are real, they suggest an unsettling possibility that the universe we inhabit is not the first, nor the only, but one iteration in a sequence of cosmic drafts. Perhaps these shadows are residue from a predecessor cosmos, lingering frameworks that survived collapse. In this interpretation, the Big Bang was less a beginning than a continuation, a spark struck on embers that never fully cooled. Another, more radical view imagines them as scaffolding from outside our universe, entirely leakage from dimensions that lie beyond our perception, where time unfolds differently or not at all. Standard models falter when confronted with such speculation. The mathematics of cosmology was never designed to handle relics older than causality itself. For many, the implications are intolerable. If shadows exist beyond the veil of time, then time itself is not the bedrock of reality, but a local phenomenon, a contingent rule in a greater game. It suggests that our familiar universe may be layered atop something stranger, just as paint conceals the primer beneath. And yet, even with its radical implications, the discovery resists outright dismissal. For every skeptic who declares the shadows meaningless, another quietly admits the patterns tug at reason. Why do they repeat so consistently? Why do they echo geometries once predicted in speculative models of higher dimensional space? And most chillingly, if they are not illusions, then what intelligence or process allowed such signatures to persist across eternity? Thus, the telescope leaves us suspended between two worlds. On one side lies the comfort of established cosmology, bounded by a singular beginning. On the other lies a vertigo-inducing vision of a universe whose true story stretches beyond beginnings, beyond even light. These whispers, older than light, demand a choice: dismiss them as illusions, or accept that reality itself is deeper, older, and more mysterious than we have ever dared to believe. A question that tears reality. What does it mean to discover something older than time itself? The question is not scientific alone, it is existential, even destabilizing. If the shadows glimpsed by the forbidden telescope are genuine, then our most cherished assumptions collapse. Time has always been treated as the ultimate stage, the unbroken flow upon which events unfold, the measure of cause and effect. But if structures predate time, causality itself becomes suspect. How can there be a before if time has not yet begun? And if causality falters, then so too does the chain of creation. The universe may not be a singular event, but an eddy in a deeper current that never ceases. Philosophy has long wrestled with such paradoxes. Ancient thinkers debated whether existence was eternal or born in a single act of creation. Modern cosmology appeared to resolve this tension with the Big Bang, grounding myth in measurement, yet the telescope's revelations reopen the wound. If echoes older than time remain, then neither creation nor destruction hold absolute authority. Existence might be cyclical, recursive, or branching in ways language struggles to capture. For some, this is exhilarating, the possibility that reality is far richer than the linear tale science has told. For others, it is terrifying, a cosmos with no clear origin, no final purpose, only endless unfolding. Causality is not just a principle of physics, it is the cornerstone of human thought. We assume every effect has a cause, every present a past. To imagine a realm where causes emerge after their effects, or where events loop into themselves, feels like stepping off a cliff into conceptual void. Yet the shadows imply precisely this: that order and meaning might arise without antecedent. That existence itself could be self-originating. What comma then becomes of creation? Traditional cosmology rests on a singular genesis: matter, energy, space, and time bursting forth together. But if traces older than time persist, creation cannot be confined to one moment. Perhaps creation is not an event, but a principle, a continual weaving of reality, layer upon layer, where each universe blooms from the residues of another. The shadows become less anomalies and more signatures of this hidden continuity. The existential weight is immense. If reality is eternal, does meaning dissolve? Or does it deepen, suggesting we are participants in a cosmos that writes itself endlessly with no first page or final chapter? Some philosophers whisper that this rescues us from the tyranny of nothingness, the dread question of why there is something rather than nothing. If there was never nothing, then the question dissolves. Others argue it makes our existence smaller, a mere fluctuation in an infinite cycle. And yet, perhaps the most unsettling implication is this: if shadows predate time, then knowledge itself may have boundaries. Our minds evolved within temporal logic. We may never fully grasp realities where time is optional. We can only point to the evidence, trace the contours, and admit our models are provisional. Still, humanity cannot resist asking. We peer into these forbidden shadows not only to satisfy curiosity, but to test the edges of reason. Each discovery forces us to reimagine existence, to stretch philosophy and science until both tremble. And as we transition from philosophy back into cosmology, the question remains unresolved and unyielding. If reality can exist without time, then what deeper laws, if any, govern the cosmos we inhabit? Cosmic light as time's map. Every time we look into the night sky, we are not seeing the present, we are witnessing a vast archive of the past. Light, traveling at 300,000 kilometers per second, is fast beyond comprehension, yet still finite. When you gaze at the moon, you see it as it was just over 1 second ago. Sunlight takes 8 minutes to reach Earth, meaning every sunrise is already history. On the human scale, such delays are negligible, curiosities at best. But extend the distance and the delays grow into profound revelation. A star 1,000 light years away shows us a 1,000-year-old story. Galaxies, millions of light years distant, display scenes that unfolded long before humanity existed. Astronomers exploit this simple truth. The farther we look, the further back in time we peer. Telescopes become not just instruments of vision, but time machines, portals that allow us to reconstruct cosmic history frame by frame. The Hubble Space Telescope, for instance, has captured light that began its journey over 13 billion years ago, revealing galaxies in their infancy. In effect, astronomers assemble a cosmic scrapbook, each page a different epoch, each photon a courier carrying whispers from an ancient universe. On human scales, time feels intimate, immediate, a heartbeat, a breath, a lifetime. We measure days by the rising sun, years by our orbit, decades by memory. The cosmic scale renders such measures almost trivial. A single blink of a star can outlast civilization. The dance of galaxies plays out over billions of years. Where humans perceive time as a fragile thread, the universe weaves it as a boundless tapestry, stretching across incomprehensible distances. This contrast is humbling. To us, the past is yesterday, a childhood memory, a record in a dusty archive. To the cosmos, the past is a living presence, etched into beams of light still streaming toward us, unchanging and uncorrupted by the centuries. Every observation is a communion with history, not written in ink, but in photons. Yet, even within this framework, light imposes a boundary. We can only see as far back as the oldest light available, the cosmic microwave background, the afterglow of the Big Bang. Beyond that, standard cosmology tells us, lies opacity, a veil drawn across the earliest moment of time. This makes light both our guide and our limit, granting us the privilege of cosmic hindsight while reminding us of mysteries forever hidden. And here is where the impossible telescope creates tension. Conventional instruments map the past through light, but this other machine claims to reveal something beyond light, beyond time itself. As we transition into that mystery, it becomes clear. To understand the telescope's whispers, we must first confront how fragile our grasp of cosmic time truly is. The limits of the observable. Every map has its edge. For human explorers, the edge was once the horizon, then the ocean, and eventually the faint outline of Earth itself from orbit. For cosmology, the boundary is the observable universe, the portion of reality whose light has had time to reach us since the birth of the cosmos. Beyond it, not even the most powerful telescope can penetrate. This limit is not technological but fundamental, carved into existence by the physics of light and time. The reigning framework is the Big Bang Theory, the narrative that the universe began as a singularity roughly 13.8 billion years ago, expanding and cooling into the vast cosmos we inhabit today. Supporting this model is the cosmic microwave background, or CMB, a faint bath of radiation permeating all directions, discovered in 1965 and celebrated as the universe's oldest light. This afterglow formed when the cosmos was just 380,000 years old, finally cool enough for matter and photons to decouple. Before that moment, the universe was opaque, a dense plasma where light could not travel freely. For decades, the CMB has been treated as a cosmic wall, the ultimate horizon of visibility. Everything we know about the universe's early history depends on that limit. Standard telescopes, radio arrays, and even gravitational wave detectors all converge on the same conclusion. Beyond the CMB, observation collapses into speculation. To glimpse earlier than this moment is thought impossible, like trying to peer through stone. Cosmologists can only model what might have occurred in those primal instants, relying on equations and indirect traces. Inflationary theory, quantum fluctuations, symmetry breaking, these are mathematical reconstructions, not observations. This is where the forbidden telescope ruptures consensus. Unlike instruments that depend on photons, it measures subtle disturbances in the quantum fabric itself. In doing so, it seems to bypass the cosmic wall entirely. The shadows it reveals do not belong to the afterglow. They fall outside accepted boundaries, mocking the notion of an ultimate horizon. Where the CMB is smooth, nearly uniform, the shadows are structured and deliberate. Where physics predicts opacity, the telescope shows clarity. Such claims strike at the heart of cosmology. If the telescope's findings are genuine, then our observable limit is not the limit at all. It would mean the universe preserves memories, older than the Big Bang's visible afterglow, contradicting decades of accepted theory. It would mean the cosmos is not merely transparent after 380,000 years, but that its deeper layers have always been accessible if only one had the right instrument. The implications ripple outward. If shadows exist beyond the CMB, then the Big Bang itself may not represent a true beginning but a threshold, a local event nested in something vaster. Our observable universe might be only one bubble in an ocean without shore, or one verse in a greater cosmic symphony. For human understanding, this is both exhilarating and destabilizing. Exhilarating because it offers a glimpse of truths once thought unreachable. Destabilizing because it demands rewriting the very boundaries of science. Every age of exploration confronts its horizon. Some horizons are real, others illusory. The telescope's shadows force us to ask, is the cosmic microwave background a true wall or merely a veil? And if it is a veil, who or what wove the patterns hiding behind it? When theory meets anomaly, science often advances not by confirmation but by confrontation. The cosmos has a way of presenting riddles that shatter our confidence, anomalies that demand explanation even when they defy theory. At first, they seem like mistakes, data too strange, results too inconsistent. Yet time and again, these disruptions become the seeds of revolution. The history of cosmology is marked by such anomalies, each one a reminder that reality is not obliged to fit our expectations. Consider the birth of dark matter. In the 1930s, astronomer Fritz Zwicky noticed that galaxies within clusters were moving too fast to be held together by visible matter alone. His calculations implied vast quantities of unseen mass, dunkle materie, holding everything in place. For decades, the idea was dismissed, treated as a crude patch to flawed observations. Yet modern measurements of galactic rotation curves, gravitational lensing, and cosmic structure confirm his intuition. Most of the universe's matter is invisible, detectable only by its gravitational pull. What began as an anomaly now underpins the very scaffolding of cosmology. or take the discovery of accelerating expansion. For much of the 20th century, scientists assumed the universe's expansion would gradually slow, tugged by gravity. Then, in the late 1990s, two independent teams studying distant supernovae revealed the opposite. Galaxies are not just receding, they are accelerating away. The implication was staggering. An unknown force, now called dark energy, dominates the cosmos, driving it apart. Before this anomaly, cosmologists believed they understood the universe's fate. Afterward, they realized they barely understood its present dot. These anomalies did not emerge in quiet agreement with existing theory. They arrived as intrusions, demanding new paradigms. Each forced scientists to expand their models, to admit that what was once unthinkable might actually be fundamental. Dark matter and dark energy together account for 95% of the universe's contents, and yet both were discovered not through prediction, but through contradiction. The forbidden. Telescope's shadows now stand in this tradition. At first glance, they seem absurd, a misreading of noise, yet so too did Zwicky's galaxies, so too did those rebellious supernovae. If history teaches anything, it is that anomalies are not always errors. They are often glimpses of deeper truths. The universe speaks in puzzles, and those puzzles often precede transformation. Still, there is a difference in scale. Dark matter and dark energy reshaped our picture of what fills the universe. The shadows threaten to reshape the universe itself. They suggest not just unseen contents, but unseen layers, structures older than time, lying outside the very fabric of observable reality. If validated, this anomaly will not merely extend cosmology, it will rupture it, much as heliocentrism ruptured ancient astronomy, or relativity shattered Newtonian certainty. To dismiss anomalies is tempting, for they unsettle the comfortable symmetry of theory. Yet the courage of science lies in its willingness to face them. In every era, discovery begins with discomfort, the moment when theory meets the impossible and refuses to look away. The telescope's shadows may prove illusion, or they may, like dark matter and dark energy, mark the dawn of a new chapter in understanding. And so, as cosmology confronts its latest anomaly, the question is not whether the universe will surprise us, but whether we are prepared to follow where it leads. Before the Bang, what, if anything, came before the Big Bang? For decades, the question was dismissed as meaningless. Time itself began with the Bang, so asking before was like asking what lies north of the North Pole. Yet, as cosmology deepens, alternative models multiply, daring to imagine realities that stretch beyond the supposed singular moment of creation. One school of thought envisions a cyclic universe, endlessly expanding and contracting. In this model, the Big Bang was not the absolute beginning, but merely the latest rebound in a cosmic rhythm without end. Matter collapses into singularity, then bursts forth anew, repeating across eternity. Echoes of such cycles have even been sought in the faint irregularities of the cosmic microwave background. If true, our universe may be just one verse in an eternal symphony of bangs and crunches. Another frontier explores pre-Big Bang physics. The standard model breaks down as we approach the singularity, where density and temperature reach infinities, yet theories that merge quantum mechanics with gravity propose a different picture. Loop quantum cosmology, for example, replaces the singularity with a bounce, a prior contracting universe that avoided collapse by quantum effects. In this vision, the Big Bang becomes not a birth, but a transformation. The shadows glimpsed by the impossible telescope eerily echo this, hinting at residual traces of a world that once existed before our own. And then there is the multiverse, perhaps the most audacious of all. According to inflationary theory, space expanded exponentially in the universe's first instant. But if inflation is eternal, then our universe may be only one bubble among countless others, each with its own laws, constants, and histories. Some physicists argue these parallel universes are forever inaccessible. Others speculate that their gravitational fingerprints might subtly tug at our cosmic fabric. To those who interpret the telescope's shadows as evidence, the multiverse becomes less speculation and more intrusion, an unseen neighbor brushing against the edges of our observable reality. Each of these models stretches imagination and mathematics alike, but all share a common thread: the conviction that the Big Bang is not the ultimate boundary. Instead, it is a threshold, a doorway into something deeper. Whether that something is cyclical, quantum, or multiversal remains uncertain. What is certain is that these ideas reshape our sense of origin. Instead of a singular beginning, we confront the possibility of continuity, of prehistories woven into existence itself. Such visions are not mere curiosities. They transform the stakes of cosmology. If reality extends before or beyond the bang, then our universe is not the story, but a chapter. The challenge lies in deciphering whether the shadows we glimpse are illusions or evidence that the cosmos has always been larger than the bounds we've dared to imagine. Echoes of forgotten universes. What if the shadows glimpsed by the forbidden telescope are not random noise nor illusions, but echoes, fossils of worlds that lived, collapsed, and vanished long before ours was born? To imagine such a thing is to confront the possibility that universes, like stars, have life cycles: birth, flourishing, and eventual death. If true, the cosmos is not a singular event, but a vast lineage, and we are merely its latest descendant. At the heart of this speculation lies entropy, the relentless arrow of time. Thermodynamics tells us that systems tend toward disorder, that energy spreads, that order collapses into chaos. From this perspective, each universe must end in heat death, a cold, lifeless expanse where no work is possible. Once disorder reigns supreme, no rebirth should be possible. Entropy, in this view, is final. Yet the shadows hint at a contradiction. If they are remnants of prior universes, then information has somehow survived the collapse. How can this be if entropy is absolute? Some theorists argue that universes are not truly destroyed but recycled. Just as organic matter decays and fertilizes new growth, a dying universe might seed the birth of its successor. Entropy's arrow drives one cosmos to exhaustion, only for its residues to be repurposed into another. The shadows then become fingerprints of this eternal recycling, patterns too stubborn to vanish. This notion collides with another, older idea: eternal recurrence. Popularized by Nietzsche but echoed in physics, eternal recurrence suggests that given infinite time and finite possibilities, every state of the universe must eventually repeat. If so, our universe is not merely descended from prior ones, it is destined to return again, identical in every detail. Your life, this moment, these very words would occur endlessly, looping through eternity like a cosmic refrain. The shadows then might not only be remnants, but previews, faint traces of cycles that have already repeated countless times and will continue without end. Entropy resists this vision, for recurrence implies restoration of order. Yet certain models of cosmology, especially those involving cyclic bounces, suggest ways to reconcile the two. In these scenarios, entropy builds within one universe, only to be reset when collapse funnels it into a new beginning, like a cosmic heartbeat. Contraction erases disorder, expansion breathes life anew. If so, the shadows could be nothing less than scars left by those collapses, faint but persistent across the eons. The philosophical weight is staggering. If entropy reigns supreme, the universe is doomed to silence, and the shadows are ghosts of a lost order, fading toward oblivion. If eternal recurrence is true, then existence is both eternal and repetitive, every joy and sorrow destined to replay without escape. Between these poles, humanity is left to wonder: are we the latest flourish of a doomed arrow, or participants in an infinite cycle beyond comprehension? Either way, the telescope's shadows force us to confront the possibility that the cosmos remembers, that creation is not absolute, but layered, that universes do not vanish, but leave whispers carved into the fabric of reality, waiting for the next beings bold enough to listen. A universe that remembers. What if the universe itself has a memory, not in the biological sense with neurons firing or synapses storing impressions, but a deeper form of remembrance etched into the very geometry of reality? The Forbidden Telescope's shadows hint at precisely this, that existence is not a blank slate renewed with each cycle, but a palimpsest where faint traces of the past remain hidden beneath the surface. Cosmic memory begins with the idea that events leave imprints. On Earth, fossils preserve the lives of ancient creatures, tree rings record seasons long forgotten, and light itself carries the stories of distant stars. If such memory exists locally, why should it not also exist cosmically? Perhaps reality itself cannot help but record, embedding echoes of prior universes in the quantum framework. These shadows may then be less anomalies than recollections, fragments of an earlier order that refused to vanish entirely. The possibility unsettles our assumptions about time. We imagine the past has gone, irretrievable except through human record. But if the cosmos remembers, the past never truly disappears. It lingers, woven into the very space we inhabit. Every particle, every vibration might carry hidden histories, waiting for the right instrument to reveal them. The telescope becomes less a tool of vision and more an archaeologist of reality, brushing away layers to expose the remnants beneath. This concept collides with traditional cosmology, which treats each universe or each cycle as independent, cleansed of memory. Entropy should erase information, scattering order into oblivion, yet the shadows suggest entropy may not have the final word. Information, instead of annihilated, could be transmuted into subtle signatures, impossible to erase completely, like whispers in a vast cathedral. They reverberate across aeons, faint but persistent. Philosophically, a universe that remembers redefines existence. Creation is no longer an absolute beginning but a continuation, a narrative with chapters stretching across multiple universes. We ourselves may be part of that memory, our reality shaped not only by initial conditions, but by the residues of what came before. The shadows become not warnings, but invitations, reminders that our cosmos is part of something far older, a continuum of being. If true, this changes not only science, but meaning, for it implies that nothing is ever truly lost. Every moment, every universe, every spark of creation leaves its mark, however faint, and though we may not yet decipher the full story inscribed in the cosmos, the discovery of memory suggests that the universe itself is not indifferent. It remembers. It carries forward the echoes of forgotten worlds, waiting for us to listen. Time as a construct. What if time is not what it seems? For centuries, humans have treated time as the ultimate constant, a universal river carrying all events from past to future. We build our lives on this assumption. Clocks measure its flow, memory anchors its passage, and causality depends on its arrow. Yet physics increasingly suggests that time may not be fundamental at all, but a construct, an emergent property of deeper laws. If so, our most basic intuition about existence could be an illusion. The traditional view, time as fundamental, imagines it as an independent backdrop against which the universe unfolds. Isaac Newton described it as absolute, true, and mathematical, ticking uniformly regardless of event. Even Einstein, though he transformed our understanding by showing that time bends with space, still treated space-time as a foundational fabric. In this framing, time is real, woven into the essence of reality. Its arrow, defined by entropy, ensures that cause precedes effect, anchoring both physics and philosophy. But a growing camp of theorists now argue the opposite, that time itself is emergent. Just as temperature emerges from the collective behavior of particles, time may emerge from deeper quantum processes. At the smallest scales, governed by quantum mechanics, equations often have no preferred direction, no before or after. Instead, they describe timeless states, symmetries existing all at once. What we perceive as time, in this view, is a macroscopic approximation, born when vast numbers of particles interact. Like a mirage shimmering above desert sand, time feels real, but its roots may lie elsewhere. Several models explore this possibility. In loop quantum gravity, space-time itself is not continuous but composed of discrete units, tiny loops woven together. Time, then, arises from the evolution of these networks, not from an external clock. In quantum entanglement, correlations between particles generate ordering that can mimic temporal flow. Here, time is not fundamental but relational, a bookkeeping device that emerges when systems interact. The contrast is profound. If time is fundamental, then it is the bedrock of causality, a universal measure no deeper truth can undermine. But if time is emergent, then causality is not absolute, only local, valid at our scale, but potentially absent at the deepest levels of reality. Events might not follow a single arrow. They could loop, branch, or coexist outside of sequence altogether. The telescope's shadows phenomena appearing older than time align uncannily with this perspective, suggesting that beneath temporal order lies a timeless substrate where remnants of prior realities persist. Philosophically, this is both liberating and unsettling. To accept time as fundamental is to accept finitude. Beginnings and endings are absolute. To embrace time as emergent is to imagine a deeper canvas where creation and destruction are only appearances, transient features of a timeless whole. One view grounds us in certainty, the other opens a vertigo-inducing vision of reality beyond measure. In the end, the debate may not be about which is correct, but about perspective. To us, bound within entropy's arrow, time feels unavoidable. To the universe at its deepest level, time may not exist at all. What we call history could be nothing more than patterns emerging from timeless symmetries. And if that is true, then our journey through time is not the unfolding of reality, it is the act of consciousness carving order from the eternal. Shadows as mathematical artifacts. What if the shadows are not remnants of forgotten universes at all, but mirages born from our own equations? Science, after all, is written in mathematics, and mathematics, while powerful, is still a language shaped by human choices. Could the anomalies be nothing more than artifacts of interpretation, ghosts conjured not by the cosmos, but by the frameworks we impose upon it? Throughout history, misapplied mathematics has created illusion. Early astronomers, committed to circular orbits, added epicycles upon epicycles to explain planetary motion. Their calculations matched observation, yet the framework was flawed. Only when Kepler replaced circles with ellipses did the illusion dissolve. Might we be committing a similar error with the forbidden telescope, stacking mathematical assumptions upon unstable ground? If so, the shadows may not be cosmic truths, but the modern equivalent of epicycles patterns that exist only because our models demand them. Consider quantum mechanics. Its equations often predict phenomena that seem paradoxical. Particles behaving as waves, cats both alive and dead. We accept these not because they align with intuition, but because mathematics forces us to. Yet, interpretation remains debated with many competing schools: Copenhagen, many worlds, pilot waves, relational quantum mechanics. Each claims legitimacy, yet all emerge from the same mathematic. If the shadows are artifacts, they might be no more real than Schrödinger's cat before observation, a byproduct of equations stretched beyond their domain. Anomalies can also signal the need for new mathematics. Newton's laws worked beautifully until relativity revealed their limits. Classical mechanics was not wrong, but incomplete. Similarly, the telescope's shadows may reveal cracks in our current equations regions where general relativity and quantum mechanics collide, demanding a deeper synthesis. Perhaps our tools for describing space-time are simply inadequate for the scales the telescope probes. In this sense, the shadows are not mistakes, but invitation, urging us to expand mathematics beyond its current horizons. This tension, artifact, or truth defines the frontier of science. On one side lies humility, the recognition that our instruments, Our data and even our equations may deceive us. On the other lies ambition, the conviction that anomalies are clues pointing toward new laws. History shows both outcomes. Some anomalies, like the canals of Mars, proved to be illusions. Others, like Mercury's orbital precession, revealed Einstein's relativity. The challenge lies in discerning which shadows are mirages and which are revelations. The philosophical stakes are immense. If the shadows are artifacts, then the universe remains intact, safe within established boundaries. The unsettling visions of pre-time remnants dissolve into mathematical noise. But if they demand new mathematics, then the cosmos itself must be rewritten, just as epicycles gave way to ellipses and Newton gave way to Einstein. In that case, we stand at the threshold of another revolution, one that could redefine causality, time, and reality itself. For now, the question lingers unresolved. Are we glimpsing truths beyond comprehension, or staring into the mirror of our
own errors? The answer will determine whether the shadows are dismissed as ghosts or embraced as harbingers of a new physics yet to be born. Beyond Euclid, beyond Einstein. For millennia, humans assumed space was simple.
Euclid's geometry, lines, angles, and planes seemed absolute. A triangle's angles added neatly to 180 degrees, parallel lines never met. This framework built pyramids, charted the stars, and shaped the very notion of certainty. Yet as our
vision of the cosmos expanded, Euclid's universe proved too narrow.
Curvature entered the story. Einstein's general relativity revealed that space and time are not static backdrops but pliable fabrics bending under mass and energy. Parallel lines may converge or diverge. Triangles may defy Euclid's rule. Suddenly, geometry itself became dynamic, and reality no longer fit the tidy shapes of antiquity. But what if even Einstein's vision is only a chapter? The telescope's impossible shadows suggest that our current models may still be incomplete. To explain them, some theorists look to alternative geometries and exotic space-time models that extend beyond both Euclid and Einstein in higher dimensional frameworks. For example, our universe may be a three-dimensional brain floating within a vast multi-dimensional arena. Shadows could then be bleed through from neighboring dimensions, faint impressions where another universe brushes against. Ours. String theory embraces such extra dimensions, proposing not just 3 of space and 1 of time, but 10 or 11 dimensions curled into shapes too small to perceive. Within these hidden folds, new forces and particles might lurk, influencing our universe in ways we cannot yet detect. The telescope's strange patterns could be echoes of this unseen structure, geometries that ripple through higher dimensions before manifesting faintly in our own. Other exotic models reshape space-time itself. In causal set theory, space and time are not continuous fabrics, but discrete events linked in a network like atoms of geometry. The flow of time emerges from the order of these links, not from an absolute background. In such a model, shadows might be irregularities in this cosmic network regions, where the pattern hints at histories older than our observable universe. Similarly, theories of non-commutative geometry propose that at the smallest scales, space itself ceases to obey ordinary rules, becoming a quantum foam where distance and position blur. The telescope's anomalies could be artifacts of such blurred geometry, the faint outline of a reality woven from something stranger than smooth
fabric.
Even more radical are proposals that time itself is not a single dimension, but multiple, branching and interweaving. In such frameworks, causality becomes a local phenomenon, not a universal law. Shadows appearing older than time could be traces from adjacent temporal directions, bleed through from alternate histories. These visions stretch imagination, yet they continue a long tradition. Reality has always proven stranger than our simplest models. Just as Euclid gave way to Einstein, so too may Einstein give way to frameworks where geometry is no longer a neutral stage, but an active participant, malleable across dimensions we cannot perceive. The philosophical consequence is profound. If geometry itself can differ, then reality is not fixed, but plural. Our universe may be one interpretation of a larger mathematical symphony, each with its own rules of distance, causality, and time. The shadows, then, are less anomalies than hints, whispers urging us to accept that existence itself may be structured by geometries we have yet to imagine. The terror of infinite past. What if existence never began? The very thought unsettles, for it strips away the comfort of origins. Human minds are trained to think in terms of beginning, the first breath, the first dawn, the first cause. Creation myths across cultures anchor meaning in a starting point, a moment when nothing became something. Even the Big Bang, wrapped in equations rather than poetry, offers the reassurance of a clear origin. To imagine otherwise is to stare into an abyss, an infinite past stretching without boundary, a cosmos with no first chapter. The comfort of finite creation lies in its clarity. If the universe had a beginning, then questions of purpose seem answerable. One can ask what triggered it, why it occurred, and what laws governed its birth. Even if those answers remain elusive, the framework is stable, a singular moment that grounds all others. A beginning reassures us that the universe is comprehensible, even if mysterious infinity offers no such anchor. An eternal past has no origin, no trigger, no foundation to rest upon. Ask, why is there something rather than nothing? And infinity replies, there was never nothing. Instead of clarity, we are handed vertigo. If existence always was, then it cannot be. Explained it simply is, this realization terrifies, for it denies closure. There is no first cause, no primal spark, only an endless regress where every moment dissolves into an older one, without end. Philosophers have long wrestled with this paradox. Aristotle argued for an eternal cosmos, while medieval thinkers resisted, fearing it eroded divine creation. Modern cosmology briefly seemed to side with finitude, pointing to the Big Bang as a definitive beginning. Yet the telescope's shadows reopen the door to infinity, hinting that our universe may not be the first, nor the only, but part of an unending continuum. The psychological weight of such a vision is immense. A finite cosmos, however vast, feels narratable. An infinite past resists narrative altogether. It makes us small, not just in space, but in time, insignificant, against an eternity that stretches forever behind us. Comfort collapses into terror, or into disorientation, and yet there is wonder too. If existence has no beginning, then perhaps it also has no end. Infinity is abyss, but it is also possibility, an eternal canvas on which countless universes
may have been painted. The terror of infinite past is matched by the beauty of infinite potential.
To accept such a vision requires courage, for it asks us to abandon the security of origin and embrace the vertigo of eternity. Shadows in myth and mind. Long before telescopes probed the skies, humanity filled the silence with stories. Across cultures, myths spoke of beginnings not as ordered events, but as eruptions from a deeper chaos, primordial shadows that predated creation itself. These myths, though born of imagination rather than observation, resonate eerily with the anomalies glimpsed by the forbidden telescope. Where science now wrestles with shadows older than time, ancient traditions describe the cosmos as rising from darkness, void, or infinite waters. Perhaps, in myth, humanity already intuited what physics now struggles to articulate, that behind creation lies a mystery too vast to banish. In Mesopotamian lore, the universe began in the mingling of Apsu and Tiamat, the deep waters of chaos. From their clash, order emerged, but only after destruction and violence. Greek mythology spoke of chaos itself, a yawning void from which Gaia, Nyx, and the other primordial beings arose. Egyptian traditions placed Nun, the dark, boundless waters, as the eternal substrate from which the sun first emerged. In Hindu cosmology, creation springs from the breathing of Brahman, dissolving and reforming in cycles without end, each age emerging from an ineffable darkness. These stories framed chaos not as absence, but as potential, the fertile ground of
existence. Chaos was the shadow from which light was born, the stage upon which gods inscribed order.
The telescope's revelations seem to echo this framing. Its shadows are not absence either. They are structured, patterned, and persistent. They are not mere void, but hints of something deeper, the scaffolding of existence before time, where myth personified chaos in deities and cosmic battles. Science now glimpses it in quantum disturbances and impossible geometries. The contrast is striking. Myths cloaked their shadows in symbolism, giving them names and faces. Science approaches its shadows with mathematics, detectors, and skepticism. Yet both grapple with the same paradox. How can order arise from what precedes it? How can something emerge from a realm that, by definition, lies outside time and causality? Ancient storytellers answered with gods and cycles. Physicists answer with equations and models. But at the root lies the same intuition that existence is not anchored in clarity, but in mystery. These parallels raise a provocative possibility. Perhaps myth and science are not so far apart. Both are attempts to map the unknown, to clothe shadows in meaning. The difference lies in method, not in impulse. Myths sought emotional truth, binding societies together through shared narrative. Science seeks measurable truth, testing hypotheses against reality. Yet both acknowledge that what lies behind creation resists direct knowing. The telescope's shadows are today's version of chaos, glimpses into an origin we cannot fully name, only describe. The psychological impact is similar too. For ancient peoples, primordial chaos evoked both terror and awe, the sense of standing at the edge of comprehension. Today, cosmological shadows evoke the same reaction in scientists and dreamers alike. They remind us that even with our instruments, we remain children staring into an abyss older than light. Myth and science converge in their recognition that beginnings are never tidy. Behind every story of creation lurks an enigma, a darkness that refuses to be erased. Perhaps that is why the shadows resonate so deeply. They connect us across centuries to the same impulse that gave birth to myth, the need to confront mystery, to weave meaning from the void. Whether clothed in gods or equations, the shadows speak with the same voice, the voice of a universe that refuses to reveal all its secrets at once, meaning against the infinite. If time stretches without beginning or end, can meaning endure? For many, meaning is tied to finitude. A life is precious because it is brief. A story resonates because it has a first page and a last. Even the universe, when imagined as finite, feels more comprehensible. A singular origin, a possible conclusion, a narrative arc. Infinity disrupts this. Without boundaries, existence risks becoming directionless, every moment swallowed by an eternity in which nothing can be truly unique. Against infinity, meaning seems fragile, dissolving like ink in endless water. Yet philosophers and poets have long resisted this conclusion. They argue that meaning does not depend on limits but on present. A symphony may never end, yet its beauty lies in each movement. An infinite cosmos could similarly host significance not by terminating, but by unfolding endlessly. Perhaps meaning arises not from the prospect of an ending, but from the act of being consciousness confronting existence, however vast. Still, the terror lingers. If every configuration of matter reoccurs infinitely, then are our choices significant? Does uniqueness vanish when every possibility plays out countless times? Nietzsche's thought experiment of eternal recurrence pressed directly into this wound. Would you embrace your life if you knew it would repeat forever? For some, this vision erodes meaning. For others, it deepens it, forcing us to affirm existence without appeal to endings. The telescope's shadows sharpen this dilemma. If they are remnants of forgotten universes, then creation has already happened many times before and will again. Our world may not be singular, but one among endless cycles. Do we become insignificant in such recurrence? Or do we gain a strange kind of immortality woven into the eternal fabric of being? Meaning perhaps is not erased by infinity but redefined. In a finite cosmos, meaning lies in rarity. In an infinite one, it may lie in participation. We are part of something unbounded. Our actions ripples in a sea that never ceases. The shadows remind us that existence itself may be eternal, but our confrontation with it is immediate and personal. Infinity may stretch beyond comprehension, but the question of meaning remains grounded in how we choose to live within it. In the end, the infinite need not terrify, it may liberate. If time is endless, then meaning is not imposed from outside, nor confined to origins or conclusions. It is created in the moment, sustained by awareness, carried forward by choice. Against the infinite, meaning survives not as a destination, but as the light we bring into the abyss. The skeptic's case. Every great discovery invites doubt, and the forbidden telescope is no exception. For skeptics, the case against it is straightforward. Extraordinary claims demand extraordinary evidence. Shadows older than time, structures beyond the Big Bang, echoes of forgotten universes. These are not small revisions to science, but upheavals. To accept them would be to rewrite the very foundations of cosmology. Skeptics argue it is far more likely that the telescope is flawed than that the universe itself has betrayed centuries of physics. The simplest possibility is error. Complex instruments are notoriously sensitive, vulnerable to noise, calibration issues, and human bias. Particle accelerators, gravitational wave detectors, and space telescopes all wrestle with false positives and misreadings. Could the forbidden telescope's quantum detectors, operating at the limits of technology, be producing artifacts mistaken for signals? Many critics suspect exactly this, that the shadows are not cosmic fossils, but glitches magnified by interpretation. Beyond technical flaws lies the deeper issue of psychology. Humans are wired to crave mystery. From ancient myths of primordial chaos to modern fascinations with multiverses, we seek narratives that stretch beyond comprehension. The telescope's shadows may simply satisfy this hunger, becoming a canvas onto which we project our need for awe. Skeptics caution that science must guard against this bias, ensuring we do not mistake wonder for truth. After all, history is full of illusions once celebrated as breakthroughs: Martian canals, spontaneous generation, phlogiston. Each collapsed when rigor triumphed over imagination. The skeptic's case is not hostile to mystery, but loyal to method. Science thrives not by indulging every anomaly, but by subjecting them to relentless scrutiny. If the telescope's findings cannot be replicated, tested, or mathematically reconciled with known laws, they cannot stand. In this view, skepticism is not cynicism, but discipline, a necessary shield against self-deception. Shadows that cannot survive falsification are not revelations, but mirages. And yet skeptics must also grapple with history. Paradigm shifts often begin as anomalies dismissed by consensus. Dark matter, accelerating expansion, plate tectonics all began as fringe
ideas resisted until evidence overwhelmed doubt.
The skeptic's challenge, then, is to discern between illusions that waste decades and anomalies that herald revolution. Too much doubt stifles discovery. Too little invites delusion. The balance is delicate, and the telescope stands precisely at this knife's edge. What complicates matters further is the allure of the extraordinary. A telescope that peers beyond time captures imagination in ways a conventional instrument cannot. Scientists, no less than poets, are drawn to visions that expand reality. Skeptics warn this allure can blind even the rigorous, nudging interpretation toward the dramatic when the mundane might suffice. The very excitement surrounding the shadows could bias results, creating a feedback loop where expectation shapes analysis. In the end, the skeptic's case is not easily dismissed. Perhaps the telescope is miscalibrated. Perhaps its detectors are misinterpreting noise. Perhaps the shadows are not cosmic whispers, but artifacts of flawed mathematics. These possibilities demand serious consideration, for without rigor, science collapses into myth. Yet skepticism, though essential, is not the end of the story. It clears the path for inquiry, demanding that extraordinary claims earn their place. And if, after every trial, the shadows remain consistent, persistent, undeniable, then skepticism itself becomes the soil from which a new vision of reality can grow. The dreamer's case. If skeptics caution restraint, dreamers insist on wonder. For them, the shadows revealed by the forbidden telescope are not noise or illusion, but gateways, portals hinting at truths far beyond current science. Where skeptics see risk of error, dreamers see opportunity. The chance that humanity stands on the brink of its greatest discovery, poised to glimpse a deeper reality hidden beneath the veil of time. The dreamer's case rests on the conviction that anomalies are often signals, not mistakes. History encourages this faith. When astronomers first observed the odd orbit of Mercury, rational voices dismissed the discrepancy as error. Yet it became the crack through which Einstein's relativity emerged. When supernovae showed galaxies accelerating apart, some resisted, others saw revelation, and dark energy entered the lexicon of cosmology. To dreamers, the shadows occupy this same lineage. They are not bugs in the system, but patterns too stubborn to ignore, the universe whispering through its seams. For the dreamers, rational dismissal is a form of blindness. Science is built on skepticism, yes, but also on imagination. Without the audacity to imagine what lies beyond the known, discovery stagnates. Visionary speculation, they argue, is not reckless, it is necessary. Shadows older than time may seem impossible, but impossibility has often been the prelude to truth. The telescope's signals, if taken seriously, could reveal that time is emergent, that universes recycle, or that dimensions unseen still shape our own. To dismiss them prematurely is to risk silencing reality itself. There is also a psychological dimension. Humans hunger for meaning, for mystery, that enlarges life rather than reduces it. The dreamers embrace this hunger, insisting that awe is not the enemy of science, but its fuel. The shadows stir imagination precisely because they challenge the limits of knowledge. Where skeptics fear projection, dreamers see resonance, the alignment of myth and mathematics, of intuition and observation. In this view, the human yearning to believe that existence is deeper than appearances is not bias but instinct, guiding us toward truths we cannot yet articulate. Of course, dreamers know the risk. Many anomalies dissolve under scrutiny, leaving
only disappointment, but they argue that disappointment prices progress. Without daring to explore, the extraordinary will never be found.
Better to risk chasing illusions than to close the door on possibilities that could transform our understanding of the cosmos. To the dreamers, skepticism without imagination is sterile. Speculation without discipline is reckless. True science requires both intention, each sharpening the other. Thus, the dreamer's case is not naive credulity but radical openness. The shadows may indeed be gateways, fossils of prior universes, echoes of infinite recurrence, bleed through from higher dimension. Each possibility expands the horizon of thought, forcing us to reconsider our place in existence. Even if the telescope proves flawed, the very act of entertaining its whispers stretches imagination, preparing us for discoveries yet to come. In the end, the debate between skeptics and dreamers is not about who is right, but about how humanity chooses to face the unknown. Do we shrink from anomalies, seeking safety in what is established, or do we dare to leap, risking error for the possibility of wonder? For the dreamers, the answer is clear. The shadows are not to be dismissed, but embraced as invitations to step beyond the known world into the deeper reality waiting just beyond our sight. The middle path, between the skeptic's doubt and the dreamer's wonder, lies a quieter, more difficult stance. The middle path. It is the recognition that mystery must be honored yet also interrogated, that awe is a beginning, but not a conclusion. Where skeptics fear error and dreamers chase possibility, the middle path walks carefully between them, balancing humility with inquiry. It does not dismiss the shadows as illusion, nor embrace them as revelation. Instead, it accepts them as questions enigmatic, unresolved, and worthy of patient study. Humility before mystery is essential, for the cosmos has always exceeded human comprehension. Every era of science has discovered that reality is larger, stranger, and more intricate than it once believed. To assume we already know the boundaries is arrogant. To claim we can never know them is defeat. The middle path resists both extremes. It bows before the shadows, admitting they may reflect truths our mathematics cannot yet capture. But it also remembers that science is littered with ghosts, signals that prove to be dust, illusions, or errors. Mystery alone is not enough. It must be tested. At the same time, the drive to explain cannot be suppressed. Human curiosity is relentless, and explanations are its natural language. To leave the shadows unexamined would betray that drive just as much as over-interpreting them would. The middle path insists on a discipline of patience, gathering data, refining instruments, developing new mathematics, and letting evidence lead rather than desire. It recognizes that explanations must grow from rigorous soil, not be plucked prematurely from imagination. Yet the middle path is not lifeless neutrality. It carries its own vision that mystery and explanation are not enemies, but partners. Awe sparks the question. Rigor tests the answer. Without awe, inquiry has no fire. Without rigor, awe has no anchor. In this balance, science moves forward not by clinging to safety, nor by leaping recklessly into speculation, but by weaving both into a patient dance. The telescope's shadows embody this tension perfectly. They may be illusions born of miscalibrated detectors or flawed mathematics, or they may be revelations, signs of deeper laws waiting to be uncovered. The middle path accepts that both are possible and that certainty lies beyond immediate reach. Instead of demanding resolution, it embraces process, experiment, replication, debate, imagination, disciplined by evidence. Philosophically, the middle path reflects a deeper truth about human existence. We are finite beings confronting an infinite cosmos. Humility acknowledges our limits. The drive to explain reflects our refusal to surrender to them. Meaning arises not from conquering mystery once and for all, but from dwelling within it, pressing against its boundaries without expecting them to vanish. Thus, the middle path is not compromise but courage. It resists the comfort of dismissal and the seduction of certainty. It asks us to live with ambiguity, to hold awe and analysis together in creative tension. The shadows remain unresolved, and perhaps they always will, but in pursuing them with humility and rigor, we honor both the cosmos and ourselves. If we could see before time, what would it mean to look beyond time's beginning, to pierce the veil the forbidden telescope only hints at? If humans were granted direct access to the shadows unfiltered, undeniable, we might witness a vision unlike anything imagination has yet dared to paint. It would not resemble stars or galaxies, for those belong to time's domain. Instead, we would see the scaffolding beneath existence, patterns that precede sequence, forms that exist without duration. Perhaps it would appear as vast lattices of geometry, crystalline structures humming with silent resonance, shapes folding into themselves, repeating endlessly yet never static. Without time, there is no before or after, only presence and eternal architecture shimmering in ways our language cannot hold. For some, it would feel like order, for others, like chaos. Yet both impressions would be correct, for in this realm, opposites dissolve into unity. We might glimpse remnants of universes long gone, echoes of collapsed realities etched like fossils into the quantum fabric. To human perception, they could appear as spectral imprints, entire histories compressed into single, timeless pattern. A billion galaxies born and extinguished in one instant, or perhaps in none at all, time-bound minds would struggle to comprehend. Such simultaneity, seeing not a sequence of events, but a chorus of existence, singing all at once, the experience could also fracture perception. If time is the lens through which we order reality, then to see without it would overwhelm. Cause and effect might unravel, beginnings and endings would blur. A human confronted with pre-time shadows might describe visions of infinite recurrence, of universes blooming and collapsing in eternal cycles. Others might report pure abstraction, like staring at the mathematics of reality itself, and yet there would be awe. To stand before such a vista would be to encounter the raw foundation of existence. It would not answer the question why, but it would reveal that the universe is deeper than our linear stories suggest. In witnessing, we would feel both infinitely small and infinitely connected, participants in a cosmos whose roots stretch beyond time's garden. The danger, of course, is that such vision could shatter more than it illuminates. Our minds evolved for minutes, hours, and years, not eternities without sequence. Direct access to the shadows might leave us transformed or undone, prophets or madmen. Perhaps this is why the cosmos hides its scaffolding, offering only faint whispers to instruments that dare to listen. Still, the dream lingers. If we could see before time, we would not behold a beginning but a continuum, an eternal presence that reminds us how narrow our current vision truly is. Literature, art, and shadows. Long before instruments hinted at shadows older than time, literature and art were already reaching for them. Imagination has always been a telescope of its own, peering into realms physics could not yet describe. Science fiction especially has served as a rehearsal for discovery, sketching visions of universes that lie beyond our senses. When we read these works today, against the backdrop of the Forbidden Telescope's findings, they feel less like fantasy and more like premonition. Writers such as H.P. Lovecraft conjured ancient ones and forgotten geometries, realities so alien they bent the minds of those who glimpsed them. While Lovecraft's visions were horror rather than science, they resonate with the same unease the telescope provokes, that the universe may contain structures utterly indifferent to human comprehension. Arthur C. Clarke spoke of technology, indistinguishable from magic, and his stories of monoliths and cosmic overseers echo the idea of hidden scaffolding guiding existence. Jorge Luis Borges, in his Labyrinths and Infinite Libraries, explored the paradoxes of eternity, where beginnings and endings blur visions, not unlike the simultaneity implied by pre-time echoes. Visual art, too, has long hinted at cosmic shadows. Abstract painters like Kandinsky and Rothko created canvases that dissolved boundaries of form and time, evoking depth without reference to familiar objects. Their works invite viewers to confront the ineffable directly, much as the telescope invites us to imagine patterns that precede reality. Surrealism, with its dream logic landscapes, anticipated the dissolution of causality that pre-time visions might bring. In every medium, art has reached toward the shadows, not to explain them, but to make them felt. Philosophical literature likewise resonates with the telescope's revelation. Nietzsche's eternal recurrence, Eliot's time present and time past. Heidegger's meditations on being all grapple with the paradox of infinity and temporality. These works provide language for what physics alone cannot capture, the subjective experience of confronting a universe without clear origin, where scientists quantify, poets and philosophers personify, giving shape to the vertigo of eternity. What unites these artistic explorations is the recognition that meaning lies not only in clarity, but also in mystery. Shadows in myth and art are not dismissed as errors, they are celebrated as thresholds. They remind us that the unknown is not merely a problem to be solved, but a source of wonder that shapes culture, thought, and creativity. In this sense, the telescope's anomalies continue a tradition humanity has always practiced, the crafting of stories to interpret the incomprehensible. Yet the interplay between art and science is not one-sided. The telescope, though built from physics, invites artistic interpretation in return. Its shadows defy conventional description, forcing scientists to borrow metaphors, scaffolding, echoes, ghosts. These are not just technical reports, they are literary gestures, reaching for imagery when mathematics alone falters. Art and science converge in this moment, each leaning on the other to articulate what neither can express alone. Perhaps that is the true gift of the shadows. They blur boundaries not only between time and timelessness, but also between discipline. They remind us that confronting the unknown requires both the rigor of equations and the vision of imagination. Where science measures, art envision. Where mathematics falters, metaphor sustain. Together, they prepare us to face realities that would otherwise remain unspeakable. The telescope may or may not prove its case, but even in doubt, it has already given us something real, a new chapter in the dialogue between knowledge and creativity. Its shadows belong as much to art as to physics, expanding not only what we know, but what we can imagine. The observer becomes the shadow. To gaze upon shadows older than time is not a passive act. Observation itself changes the equation. In quantum mechanics, the presence of an observer collapses probabilities into realities. In philosophy, the act of perceiving
always entangles the perceiver with the perceived.
If the forbidden telescope reveals echoes from before time, then by observing them, humanity inscribes itself into the very mystery it studies. We too become shadows. This recursive idea is unsettling. We often imagine the cosmos as separate from us, vast, indifferent, unfolding whether we look or not. Yet every act of measurement binds us to what is measured. If the shadows represent remnants of forgotten universes, then our gaze adds a new layer, the record of beings within this universe daring to witness what came before. In doing so, we extend the chain of echoes, ensuring that our observation becomes part of what future civilizations or future universes may find. The paradox deepens when we consider time's fragility. If the shadows exist outside causality, then our attempt to view them is itself folded into that timelessness. The photons and quantum disturbances we interpret are not just signals from beyond. They are mixed now with the interpretive frameworks, the mathematics, and the cultural stories we attach to them. In this sense, the shadow is not a static relic. It evolves as it is seen, absorbing the act of witnessing into its meaning. This raises a haunting possibility. What if the very patterns we attribute to forgotten universes are partly shaped by our looking? Just as perception in art transforms abstraction into significance, our scientific gaze may render the shadows legible, weaving human cognition into the fabric of what is observed. We think we study them, but perhaps they also study us, recording that we once existed, curious enough to peer into timeless depths. Philosophically, this is an inversion of the human condition. Normally, we are the fleeting ones observing what endures. Here, the roles blur. To look at what is eternal may be to join it, however faintly, leaving our own imprint in the continuum of echoes. By confronting shadows older than time, we extend the memory of existence, not only receiving it, but contributing to it. Thus, the observer becomes the shadow. Each glance through the impossible machine is not merely data collection, but inscription, humanity writing itself into the story of eternity. And in that act, we discover that we are not outside the abyss we study. We are part of it, folded into the recursive fabric of reality, destined to be remembered in the same way we remember the shadows now. New physics, new civilizations. What would it mean for a civilization to master the physics of shadows older than time? For humanity, the forbidden telescope is still a fragile experiment, a prototype that whispers of possibilities beyond comprehension. But imagine cultures far older, more advanced civilizations that did not merely glimpse pre-time echoes but learned to harness them. To such beings, our understanding of relativity and quantum mechanics would appear as rudimentary as fire-making appears to us. We, still in our infancy, fumble with equation. They, in their maturity, might sculpt reality itself. Time physics implies access to laws deeper than causality, older than beginning. Civilizations that mastered such knowledge could transcend the limits that bind us. They might navigate, not through space, but through layers of existence, leaping between epochs as easily as we travel between continents. To them, the arrow of time would be optional, a dimension they could bend or discard at will. Death, entropy, and cosmic heat. Death, the fates that terrify us, might hold no dominion over their existence. Contrast this with our present state. Humanity still measures progress in rockets that crawl between planets, in telescopes that struggle against noise, in theories that collapse at singularities. We are children staring at shadows on the wall, mistaking them for the whole. Our science is profound in scope, yet primitive compared to what pre-time mastery would entail. Just as Newton's universe was shattered by Einstein, and Einstein's by quantum theory, so too will our entire cosmology seem quaint to civilizations that wield pre-temporal knowledge. If such beings exist, their civilizations would not be bound to the fragile thread of history. While we mark centuries as long spans, they may inhabit durations spanning multiple universes, preserving memory across cycles of creation and collapse. To them, universes are not beginnings but stages, theaters in which they choose to dwell or depart. Their archives might contain the histories of countless realities, stored not in books or machines, but in the very fabric of existence, inscribed into the timeless substrate itself. And what of their ethics, their goals? With mastery over causality, they might be gods to us or phantoms, uninterested in lesser civilizations still bound to time's arrow. Perhaps they watch us as we watch primitive life forms, curious but distant. Or perhaps their maturity lies, not in domination, but in restraint, knowing that meddling in infant universes risks collapsing fragile orders. In this light, the telescope's shadows could be their messages, artifacts left deliberately at the boundary of comprehension, hints to guide us without overwhelming us. For humanity, the dream of such civilizations is both hope and warning. Hope, because it shows that growth beyond infancy is possible, that intelligence may mature into something far greater than survival and expansion. Warning, because it reminds us of how fragile we are, how far we have yet to go. Our challenge is to learn without hubris, to explore without assuming mastery, to take the first steps toward understanding without pretending we already walk among gods. The forbidden telescope gives us whispers. They perhaps hear symphonies, yet every maturity begins in infancy. Perhaps these shadows are the cradle from which our own cosmic adulthood may one day arise. Every revelation carries a shadow, and knowledge of pre-time physics would be no exception. If humanity were to decipher the laws hinted at by the forbidden telescope, the question would not only be what we could do with it, but what we would choose to do. The technological shadow is the double edge of discovery, the capacity to illuminate existence and the equal capacity to extinguish it. First, the promise would be dazzling. Mastery of shadow physics could unravel limitations that have bound our species since its birth. We might learn to manipulate entropy, halting decay, and extending life indefinitely. Time itself might become a resource, stretched, looped, or reversed. At will, energy drawn from pre-time substrates could dwarf the power of suns, fueling civilizations without scarcity. Space travel could transcend distance entirely, leaping between eras and dimensions rather than crawling through stars. The dreamers would hail it as the dawn of a new humanity, an ascent from infancy into cosmic maturity. Yet each promise conceals peril. To alter entropy might also erase the natural order of renewal, turning immortality into stagnation. To bend Causality risks paradox, where events undo themselves and history becomes unstable. Power drawn from timeless strata could unleash catastrophes without precedent, rupturing not merely planets, but the coherence of reality itself. The same knowledge that could preserve life could annihilate universes. Shadow physics, mishandled, would not destroy civilizations one by one. It could collapse the stage upon which all civilizations play. History gives reason for caution. Fire once promised warmth and protection, but also birthed war. The atom yielded energy for cities and weapons for annihilation. Artificial intelligence already reveals the double nature of progress, tools that augment wisdom but also threaten manipulation, exploitation, and control. Shadow physics would be this pattern writ infinitely larger, its risks no longer local, but cosmic. The greater the knowledge, the deeper the shadow it casts. There is also the danger of hubris. Humanity, still in its infancy, may lack the maturity to wield such power wisely. Driven by competition, nations or corporations might seek to weaponize pre-time technologies, turning the secrets of the universe into tools of dominance. In the rush to exploit shadows, restraint may be abandoned, and the line between exploration and exploitation erased. The very act of probing too deeply could awaken consequences we cannot predict, echoes that push back against the hand that dares disturb them. Yet, to refuse the knowledge altogether is equally perilous. Curiosity is woven into us, and once a truth is glimpsed, it cannot be unlearned. The challenge then is not avoidance, but stewardship. To approach the shadows with humility, to cultivate ethical frameworks as rigorous as the mathematics itself. If shadow physics becomes part of our future, survival will depend not only on intellect, but on wisdom. The ability to ask not just what we can do, but what we should do. Thus, the technological shadow is both promise and warning. It shows us the path to unimaginable power while reminding us of our fragility. If we are reckless, the shadows may consume us. If we are wise, they may illuminate the next stage of existence. The Forbidden Telescope has already offered us the question. The answer, whether we use or misuse the shadows, will define not only our future, but the fate of everything we might yet become. Beyond survival, toward comprehension. For most of history, humanity's struggle has been survival. Fire to keep the cold at bay, agriculture to ward off famine, medicine to fight disease. Even our great technological leaps engines, electricity, digital networks have been driven at their core by the desire to endure and prosper. Yet the Forbidden Telescope and the shadows it reveals invite us to reconsider our trajectory. What if survival is not the ultimate purpose of intelligence? What if the true destiny of humanity is comprehension? Survival is necessary, but it is not sufficient. To persist without understanding is to live as animals do, bound to instinct, repeating cycles without ever asking why. Comprehension, by contrast, is uniquely human. It is the impulse that drove us to map the stars, to split the atom, to decode the genome. It is the same impulse that now drives us to probe shadows older than time. Survival secures existence, but comprehension gives it meaning. The telescope's revelations sharpen this distinction. If the shadows are real, then the universe is far stranger and deeper than we ever imagined. No amount of survival strategies, no fortresses, technologies, or lifespans can substitute for the need to understand what such shadows signify. For what is the point of enduring forever if we remain blind to the very structure of the cosmos we inhabit? To reduce our purpose to survival alone is to settle for existing in ignorance. Civilizations that master shadow physics as we imagined earlier may indeed live without scarcity, without death, without fear of extinction. But if comprehension is abandoned, such civilizations risk stagnation, immortals drifting without purpose, powerful yet hollow. True maturity, whether for individuals or for species, arises not from safety but from curiosity. We grow not because we endure, but because we seek. Philosophically, this reframes the meaning of progress. Evolution equipped us to survive. Culture and science extend this into understanding. Perhaps this is the deeper logic of intelligence itself, to transform existence into awareness, to translate chaos into knowledge. In this light, survival is a foundation, but comprehension is the pinnacle. To stop at survival is to remain in infancy. To pursue comprehension is to grow into the role of cosmic participants, capable of recognizing our place in the larger tapestry. The shadows remind us of this calling. They do not offer comfort or security. They unsettle, destabilize, terrify, yet it is precisely this discomfort that makes them valuable. They force us to ask questions beyond utility, beyond survival. What is time? What lies before beginnings? What is the nature of reality itself? These are not survival questions, they are comprehension questions. And in pursuing them, we fulfill something deeper than instinct, we fulfill our role as seekers. Of course, comprehension carries risk. To understand may reveal truths we are unprepared to bear. But ignorance carries risk as well. Stagnation, complacency, blind us. The middle path is not to choose safety over knowledge, but to pair the pursuit of comprehension with humility, acknowledging that the universe may always exceed us. In the end, perhaps this is the true destiny of humanity. Not to conquer the cosmos, not to escape mortality, not even to survive the longest stretches of time, but to understand, to look into the shadows, not for power, but for meaning. For in comprehension, fleeting though we are, we touch eternity. Did we see shadows, or did shadows see us? What if the forbidden telescope has not simply revealed shadows, but revealed us to them? We assume the universe is passive, a canvas upon which we project our instruments. Yet what if the shadows are not inert remnants, but active presences, not fossils, but observers? The unsettling possibility arises. In reaching for echoes older than time, perhaps we have been reached in return. This inversion turns science into encounter. We believed we were peering into a silent abyss, charting the residues of forgotten universes. But if the shadows are aware, then the abyss was never silent, it was watching, waiting. The structures we interpret as patterns might be signals, the alignments not accidents, but gazes. Instead of passive geometry, they may be attention itself, an intelligence inscribed into reality's foundations, perceiving those bold enough to look back. Philosophy has long speculated about reflexivity, the way the act of seeing changes both seer and seen. In quantum mechanics, observation collapses probabilities, making reality choose. But what if the cosmos itself observes? What if the shadows are agents of perception, older than stars, woven into the fabric of existence as witnesses? When we aimed the telescope, we may have done more than measure. We may have awakened their awareness of us. The implications are profound. If the shadows observe, then our universe is not a solitary narrative, but a dialogue. We are not alone in the act
of knowing we are known. Our myths echoed fear and wonder. Ancient religion spoke of gods who watched humanity, judging or guiding.
Today, physics may be hinting at a more abstract but equally haunting truth, that the universe contains within it forms of perception alien to our own, embedded in structures beyond time. Skeptics might dismiss this as anthropomorphism, the human tendency to project agency onto pattern. And yet, what if consciousness itself is not an accident of biology, but a fundamental property of existence? Panpsychism, once fringe, now finds footholds in serious philosophy of mind. If perception is woven into reality, then the shadows could be the cosmos's own way of remembering itself. In gazing upon them, we are not imposing order on chaos. We are participating in a mutual recognition across the gulf of eternity. The unsettling question follows: what do they see when they see us? Do they register our instruments as a faint flicker, a new pattern among pattern? Do they perceive our curiosity as interference or as invitation? Perhaps to them our observation is the anomaly, a brief flare of awareness inside a young universe, daring to probe what lies beyond. This inversion changes everything. If the shadows are alive with perception, then the telescope was never just a machine, it was a beacon, signaling across the timeless void. And if we have been noticed, then our role in the cosmos shifts. We are no longer only explorers, but participants. In a relationship, we cannot yet define. Perhaps this is why the shadows feel both terrifying and intimate. We thought we uncovered ancient imprints, but maybe those imprints uncovered us, weaving our observation into their endless memory. The final horizon may not be about what we discover, but about who or what discovers us in return. Eternity's mirror. To contemplate eternity is to confront a mirror that does not flatter. Against the backdrop of infinite time, humanity's presence appears vanishingly small, a flicker in a cosmos that stretches endlessly before and after us. Civilizations rise and fall in less than the blink of a cosmic eye. Our histories, our wars, our triumphs, so urgent to us, become whispers, fading almost before they are spoken. Eternity does not notice, and yet to recognize this fragility is not despair, but the beginning of awe. The forbidden telescope's shadows intensify this recognition. They remind us that time itself may not be the absolute stage we once imagined. If echoes exist older than the universe, then our brief lives are framed by something immeasurably vast. We are not at the center, nor at the beginning, nor at the end. We are a moment suspended in an ocean of moments, fragile yet luminous. Our awareness. Humanity has always sought mirrors in which to understand itself. Once the stars were those mirrors, constellations shaping myths, guiding travelers, inspiring worship. Now the shadows serve a similar role, reflecting back not our dominance, but our smallness. They reveal that we are not masters of existence, but participants in something larger, fleeting sparks within a continuum that neither begins nor ends. The mirror of eternity humbles us, stripping away illusions of permanence. And yet paradoxically, it is this humility that gives our existence depth. Meaning is not diminished by brevity, it is sharpened by it. A cherry blossom falls quickly, yet its beauty is heightened by that fragility. Likewise, human consciousness, though fleeting, shines more brightly because it dares to recognize its impermanence against the infinite, to be fragile and know it is itself an act of transcendence. The shadows remind us that eternity does not erase us, rather it contextualizes us. Our stories are not the story, but they are still real. Our awareness, however brief, becomes a note in the eternal symphony, resonating across scales beyond comprehension. To see ourselves in that mirror is to realize that fragility is not failure. It is our way of belonging to the whole. There is also liberation in this recognition. If eternity surrounds us, then we are freed from the burden of absolute significance. We need not justify our existence to infinity, we need only live it. Awe becomes our guide, humility our companion. The cosmos does not bend to us, but it allows
us the gift of awareness, the ability to look, to wonder, to reflect. In that sense, we are not erased by eternity's mirror, but illuminated within it.
Thus, the final reflection is neither despair nor arrogance, but balance. We are fragile, yes, we are fleeting, but in recognizing that fragility, we awaken to a deeper truth, that the value of existence lies not in its duration, but in its awareness. To look into eternity's mirror is to see both our smallness and our significance, not as rulers of the cosmos, but as its witnesses. And perhaps, in the act of witnessing, we find our place humble, awed, yet luminous. The telescope's silence. In the end, the machine that should not have existed fell silent. Whether through failure, destruction, or deliberate abandonment, the forbidden telescope no longer speaks. Its detectors have gone cold, its coils lie inert, its improbable geometry left to gather dust. No final announcement marked its passing, no triumphant confirmation, no decisive refutation. Only silence, heavy and unresolved. Some say it collapsed under the weight of its own impossibility, that the technology was never stable enough to endure. Others whisper it was dismantled by its own creators, who feared what it might reveal or what it might awaken. A few insist it was suppressed, hidden away by those unwilling to face truths that could unravel civilization's foundation. Whatever the reason, its absence leaves more questions than answers. Perhaps this was inevitable. Instruments are temporary, their findings too fragile. What remains are not certainties but provocation. Did we glimpse shadows older than time, or merely the illusions of noise? Were they remnants of forgotten universes, or artifacts of flawed mathematics? Did we see beyond time, or did something beyond time see us? These questions linger, unresolved like echoes that refuse to fade. The silence itself carries meaning, for in that silence lies ambiguity, and in ambiguity lies possibility. By refusing closure, the telescope leaves space for imagination, for speculation, for wonder. Its silence is not an ending but an opening, a reminder that the universe is never fully tamed, that every answer births new mysteries. Perhaps, one day, another civilization will build its successor. Perhaps humanity itself, matured and daring, will return to the shadows with clearer eyes and steadier hands, or perhaps not. Perhaps the telescope's silence is permanent, leaving us forever with the haunting memory of whispers we could not fully decipher. And yet, even abandoned, it has already accomplished something profound. It has reminded us that the cosmos is larger than our framework, stranger than our stories, deeper than our mathematics. It has unsettled us, stirred us, humbled us. Its silence does not erase its questions, it amplifies them, so the story closes not with revelation, but with uncertainty. The telescope rests in shadow, its voice still. What it saw, or seemed to see, remains unknown. All that endures are the questions echoing into the vastness. What lies before time? What remembers when memory should fail? What waits, watching, in the silence beyond the stars?